Hey guys, welcome back to another episode of Rosner's Notes. Today we are going to start the blissful chapter 9 where we get to start going over some geometry. In fact, I think we got about 3 chapters of it. So we get to start with chapter 9 and we got a lot of easy peasy stuff to do. So let's get it going. We have lesson 9-1 and we're going to be talking about the area of a parallelogram. Now, when I first wrote these notes out, it took me 1 page. So that may be the same for you. Now, when I taught geometry class, I got to be honest with you, today's date 3/29/19. My kids used to make flashcards for vocabulary. Always when we started another chapter in geometry, more flashcards. Sometimes we had up to 33 words, okay? So again, the language of math, you got to learn what the words mean. So we're going to start with the word called polygon. Polygon. Actually, it's made up of 2 Greek words, poly meaning many and gon meaning angle. So these are shapes that have many angles. Now the definition we used is a closed, meaning there's no open spots, geometric figure, formed by 3 or more straight lines. Now, can you think of a shape that you're familiar with, that you've seen, that exists in our world all over the place, that does not meet this definition? Yep, you're right. This means it excludes circles. Anything with a curve is not going to be considered a polygon. Now, there's some polygons with so many sides that it looks like a circle, but it really isn't, okay? So let's talk about our shape du jour. That's today in French. And that would be the parallelogram. And since it starts with the word parallel, that tells you a little bit about this particular shape. So a parallelogram is a quadrilateral. So you're learning a lot of Greek today. Quad meaning 4, lateral meaning side, so it's a 4-sided figure. Four-sided figure. Change my color. With both sets of opposite sides are parallel to each other. Okay, so opposite sides are the same length. Okay, so when we're talking about them being the same length, then we're also talking about them being congruent. Same shape, same size, okay? All right, so let's draw a picture. Actually, I'm going to do a couple different pictures. We're going to talk about some definitions and how parallelogram fits underneath. Okay, I'm going to try this again. I'm not sure what got cut off. My battery's kind of low, but I finally got it plugged in correctly. So we talked about definitions before, like we've got an umbrella of real numbers, and so those include fractions, decimals, percents, whole numbers, positives, negatives. And then we talked about inside of that was the integers, and the integers were positive and negative whole numbers. Well, inside of integers are whole numbers, and inside of integers are natural numbers, 1, 2, 3, 4, and so on. So we've got the same sort of situation going on here. So let's draw a nice little picture. Now, I'm going to take more than one screen just to tell you with the notes. So polygon is the overarching group of these geometric figures, okay? Inside of it is one particular figure that's called a parallelogram. And in a minute, I'm going to talk about one more shape that meets the definition of a polygon and a parallelogram, but we're going to hold off on that for just 1 second. Let's go ahead and draw a picture of a parallelogram, shall we? And then we're going to talk about what the names of the sides are. Now, when I want to say that opposite sides are congruent, I draw little arrows. So it's just the arrow cap. What that tells you is those two sides are parallel, okay? And then the other sides are parallel to each other. So I can't use just one triangle. I already did that with the other side. So I would use two of these double triangle heads, and then or double arrow cap heads, and that's telling you that those two blue sides are going to be congruent to each other. Okay. Now, name-wise, the top and the bottom of our shape have the same name. They're called a base, and that makes sense because they are on opposite sides of each other. Now, in order to figure out any information about a parallelogram, I also need to figure out how tall it is, and so that is called a height. Now, there's two places I can find the height of a parallelogram. I can find the height inside, like I just did, or what I can do is extend, so it's an imaginary line here, and I can extend from the top of the parallelogram to the line that contains the base, so it's just an extension of the base, and that also is the same height measurement, okay? So the height, again, is the distance from the top of the parallelogram, or we could just say, top of the we could say shape, because this is going to be true for any kind of shape when we talk about height. From the top of the shape, perpendicular to the bottom, and we're going to remind ourselves that's called the base of the shape. Okay, so that's the key. The height has to be perpendicular to the base. Okay? All right. Now, are you ready for this? Are you ready? Do you know the name of a special parallelogram where all four sides have exactly the same measurement? And before you say square, you're kind of right, but that's not what I'm looking for. I'm looking for a shape that doesn't necessarily have to have right angles. Like a parallelogram doesn't have right angles. If I have a parallelogram with right angles, he's called a rectangle, okay? Anyone get it? You got it? Shout it out. There you go. Rhombus. I was so impressed with Tiana when she was in kindergarten, and she could tell me what a rhombus was. I'm like, yes! So all a rhombus is a parallelogram with four congruent sides. Remember what congruent means? Same length. So inside of that definition of a parallelogram are all these rhombus. Okay? Now, we just mentioned that the height is perpendicular to the bottom of the shape, so let's talk about what are perpendicular lines. Now I'm going to be showing you a couple of magic tricks, not in these notes, but live on Monday when we talk about this video, so be prepared, all right? It's earth-shattering. So parallel lines are two lines. Sorry for clearing my throat there. That intersect at a right angle. And if you noticed, when I drew my height of my parallelogram, notice that little box here in the corner? That means right angle, okay? Because it meets at a right angle. It's squared. It's squared off, right? Now, what we are going to be talking about is one more thing called a formula. And I think we've probably mentioned formulas before. But the definition of a formula is an equation. So yes, there'll be equals. That shows a relationship between quantities. Now, I know what you're thinking. That has got to be the most vague adult thing I've ever heard in my life. Well, you're kind of right. Basically, what it's saying is that a formula tells us how to find something. It's using different parts of different things, and when we do math with those different parts, it gives us something else. So, obviously in this chapter, based on the title, we're going to be talking about the area of a parallelogram. So I have a formula for the area of a parallelogram. So the area of a parallelogram says this: A, which stands for area, is equal to B, which stands for the base value, times the height. And we've already established what is a base and what is a height. Okay? So we're going to do two examples, and we're going to, I think in one of them, you're going to find the area, and the other one, you're going to find the missing dimension. Okay? So I'm going to go to my next screen. Dang, I thought these were going to be the world's shortest notes. Close enough, though. So directions are going to say find the area of the parallelogram on this one. Now, often what happens is they will draw a picture and you'll have to identify the key pieces. And we're going to be told it's 4 meters from this edge to this edge. We're being told this is 17 meters, so that side is 17 meters. And then they drop down a line that is perpendicular to that 4 meter piece that came all the way down from the top of the shape. And that is going to be measuring 16 meters. Now remember our formula, A equals BH, area equals base times height. The interesting thing is, they gave us 3 numbers here. So are they trying to fool us? Yeah, they actually are. Okay, just outright, that's it. So, what number is the base? That's this 4 meters here. Okay. And what's the height? Yep, 16 is the height. Okay, so what we're going to do is go ahead and plug those numbers in. So we're going to have 4 meters times 16 meters. Now, normally you don't need to have labels in there, but I'm just showing you where the area or the label comes from. So 4 times 16 is 64. And I have an m that shows up twice, so I use an exponent. So this is read as 64 square meters. Even though the exponent comes after, I read it in front. Square meters. Always, it's not meters squared, it's square meters. Okay? Now, let me ask a quick question. What the heck is that 17 for? Wow. How would I ever use that? Well, remember that guy called perimeter? The distance around the outside edges of a shape? If I didn't know that 17, I could not figure out the perimeter of that parallelogram. So that's why they told us that. And to mess with our minds. Last example, find the missing dimension of the parallelogram. Okay, and so let me draw a picture again. Now, sometimes they will just list the information out for you, but most often it's going to be a diagram. So we're going to tell you that this is 9 inches. You're going to see, for whatever reason, a lot of times when they draw a height, they're going to use red. I don't know why. And then A equals 45 square inches. Now, looking at this, you might say, okay, I'm really not sure how to do this because it doesn't tell me the bottom, and the bottom is the base. And if you remember back to our diagram, the base is the top and the bottom. Yeah. And remember, we also said that opposite sides are parallel and the same length, which means they're congruent. So if the top is 9 inches, guess what the bottom is? Also 9 inches. Okay? That's the worst inches I think I've ever written in my life. Let's try that again, shall we? There you go. Okay? So we're going to start with a formula. And we're going to kind of color in what we have. So let's start with, I just kind of did something funky there. The 9 is going to be the base. But here comes the weird part. You ready for this? Yay! The area is 45 inches. Or square inches, excuse me. So, I substitute those numbers in their spots. 45 square inches equals 9 inches times the height. Okay? Now, do I have to use those parentheses? No, but it just makes it look a little nicer. So, I'm multiplying the variable h by 9, so the inverse operation would be to divide by 9. So I'm going to divide both sides by 9 inches. Now again, you do not need to do the math with the labels, but I need you to understand where the labels come from. So this goes away. 9 goes into 45 5 times evenly. I have 2 inches on top, so inch times inch, and I have an inch on the bottom. So an inch over an inch cancels out, and I'm just left with inches. So I'm going to reinterpret this, and I'm going to say the height is 5 inches. So dimension just means a length, a width, a height, a side length, something along those lines. All right, have fun with this, guys. See you later.